Alright class, welcome again to another edition of Mr. G's Math Notes. Today we're going to do our last section for this unit. Tomorrow we will review the unit, and Thursday we will test over the unit. Friday we will do corrections over the test. So today our last notes are all about areas of similar figures. So we have our warm-up to do first, and number 1 here. We need to find the area of a regular hexagon with a side length of 8 centimeters. So you'll remember back to the notes from last time that we need to do, so we have a regular hexagon, that means that our number of sides, n, is 6, our length of the sides is 8, and our apothem has to do with our side length and a 30, 60, 90 triangle. So because our side length is 8, divide that by 2, and then you multiply whatever you get there by square root 3 to get your apothem for a hexagon only. That only works for a hexagon. So 8 divided by 2 is 4. 4 square root 3 is our apothem. So now we use our area formula for a hexagon. It's 1/2 the area times the number of sides times the side length, or not area. Area is equal to 1/2 the apothem times the number of sides times the side length. So now we just set all this up. So 1/2 times the apothem, we just said is 4 square root 3 times n, which is 6 times 8. So first we can split one of these in half. It doesn't matter which one. I'm going to do the 8 just because it's the largest number. So we have A is equal to our area, 4 square root 3 times 6, and 1/2 of 8 is 4. And 6 times 4 is 24. And 4 times 24 is 96. So 96 square root 3. It does say it around to the nearest tenth if necessary, so we'll go and get it in a decimal. And 96 times the square root of 3 is 166.3 square centimeters. Number 2, we have the area of a square with an apothem. Now with a square giving us the apothem, all that means is that is half of our side length. So what we're going to do is take, so area for a square is side squared. The apothem is equal to 1/2 of a side length. So 14 is equal to 1/2 of s. We're going to multiply by 2 on both sides to figure out what s is. So it's 28. So we have our side length. So our area is equal to 28 squared. When you square 28, it comes out to be 784 square inches in this case. No need to round because it's a nice, pretty round number as it is. Alright, so we only have a few example problems to get through today. They all have to do with proportions. So here, areas of similar polygons. If 2 polygons are similar, then their areas are proportional to the square of the scale factor between them. So you can use any side, if we know that they're similar, and come up with a scale factor, so the corresponding 2 sides. So in this case they use FG and AB, the tops of this trapezoid. And then you just set that equal, or you square whatever you get there, set that equal to the ratio between the areas. And if you're looking for one area, you use the ratio, cross multiply, and find the other area after you square the scale factor. So our first example of this, we have 2 rectangles here. It could be squares, we don't know, but it doesn't tell us. It just says that they are polygons. In this case, they're quadrilaterals. At least we know that much. So we know we have these 2 sides, right? And they're similar because D and C, or C and D and R and S, if you look in the names, are in the same spot. So C and D, R and S. So the 2 sides we are given are the sides that are similar. So 6/9, which simplifies to 2/3. So So we're going to use our 2 over 3 as our scale factor. Now we're going to have to square that. And we know the area of the smaller rectangle is 48. So then we just need to find the area of the larger rectangle. So first thing we need to do is square the scale factor, and 2/3 squared, when you square a fraction, you square the top and the bottom, so the numerator and the denominator both get squared. So 2 squared is 4, 3 squared is 9, equal to 48 over 9, not 9, over x. Then we cross multiply, so we end up with 4x equal to 9 times 48, which is 432, and we divide by 4. So our x comes out to be 108, and our unit is inches squared. Now, this one, since it is a rectangle, or a square at least, there's actually a much easier way to kind of do this, since we know the smaller one is an area of 48, and we know for a rectangle or a quadrilateral like this, and really we don't even know it's a rectangle, it doesn't tell us anything else, so we can't assume that. But if we divide the 48 by 6, we get 8, so then we can set up our 2/3 scale factor again. Be 8 over x, we cross multiply that to get what the side PS or QR is, either way. So when you cross multiply that, you'd get 2 times 8 equal to so you have the 3 times 8, sorry, and that would be 24. Divide that by 2 and you get 12, and then 12 times 9 is 108, so these are rectangles. But again, we can't assume that. They might look like a rectangle. We don't know that those angles are right angles. It doesn't tell us that. If it did say this is a rectangle, then we could do that, but we don't know that for sure. So again, don't assume things just because it looks like it is something. So here we have two figures again. Do the same process I just explained, or we can do the process we did on the problem. And that's what we're going to do. So we have our 4 over 12, that's our scale factor. And we can simplify that. 4 divided by 2 is 2, 12 divided by 2 is 6, and both of those divided by 2 as well, so it's 1/3. So our scale factor is 1/3. You square that. The 1 goes with the smaller of our two figures, and we know that the smaller one is EFGH, which is 40 square inches. Hey, you know what? The units changed on us in here. Just noticed that. It's inches in the problem, and then it's feet suddenly in the answer choices. So we might be careful with that. We'll see what happens here. All right. So we got the 40, and then x is what we're trying to find. So we're going to square again. When you square a fraction, you square the numerator and the denominator. So 1 squared is 1. 3 squared is 9, equal to 40 over x. Cross multiply, and x comes out to be 40 times 9, which is 360 square feet. Now, I don't think that 40 is supposed to be square inches in the words in the problem. The wording should be square feet, just a guess, because 360 is the answer choice C, and that's what we get. So the 40 should be square feet for sure. If that was square inches, we'd have a whole other deal we got to figure out, and that's a big conversion, because it's in square inches, not just inches anymore. So we'd have to divide that by 144, and we're not going to do that. Obviously, that would not be the case here. We did get the 360. Okay, same process. We have a couple of triangles now instead of squares, so it's not as easy. You do have the base on one of them, so you could probably, and the base that you have is the one that you could do the area on, so you don't really have to do this process. But because the equation, or the formula for a triangle is a little more difficult than just length times width, then you can't, make it as easy as doing what we're going to do. So our scale factor here, or actually here, we are given our two. Alright, so here we are actually trying to find one of the sides. So we don't have our scale factor, but we do have the areas of the two, right? So we're going to make our formula. So we know that one side is 14 of the larger triangle. The other side that corresponds to it on the smaller triangle is x, and that's squared. So our x goes with our smaller triangle, which is RST, and the area is 50 of that one. The larger triangle has an area of 98. So what we're going to do here is work backwards. So first thing we're going to do though is we're going to square still on the left side. So we squared numerator and denominator. So that's x squared on the top, and 14 squared is 14 times 14. So that gets us 196 equal to 50 over 98. So now we can cross multiply. 50 times 196 and 98 times x squared. So 50 times 196 comes out to be 9,800. We divide by 98. And our x squared now is equal to 100. Now since x is a distance, remember when you square something, if it's both negative, so if it's negative, negative times a negative is positive still, right? So really, if you square something here, you could put a negative 10, but because we're talking about a distance, you can't have a negative length of a triangle. Doesn't make any sense. So when we square root this, we're just going to include the positive square root of 100, which is 10. Alright, so now we have one more like this. So again, two triangles. So we have two triangles here, and see that will work here. There we go. So we know that NP is the base of one triangle. It's x. We don't know it yet. Trying to find it. Area of the smaller triangle is 32. Area of the larger triangle is 72. So again, we're going to square the left side. So x squared, 9 squared is 81. Equals to 32 over 72. Cross multiply. 72x squared is equal to 81 times 32, which comes out to be 2,592. We divide by 72. X squared comes out to be 36. And again, we're only going to include the positive square root of 36, so x is equal to 6. So our answer choice should be C. Alright, one more example problem. This one is pretty simple. We just need to write out some stuff and kind of compare. So we have the original shape, that banner that he has is 15 feet by 6 feet. So the area of it, hopefully this banner is rectangular, doesn't say, but we assume that banners are typically rectangular. 15 times 6 is 90 square feet. And then he makes two additional banners. One of them is 30 by 12. So it's double the length and double the width of our original, but the area is very different. It's 360 feet squared. And then the last one, he doubles the first and only adds, adds 4 feet to the second length. So 30 times 10 is just 300 feet squared. So to show you what he did, so I'm going to label the 15 and our 6 as X and Y. So what he ended up doing was taking our X and doubling it and multiplying that by 2 times our Y, right? And really, so our area would be X times Y, right? Initially. So our new area, when we multiply this, becomes 4xy, right? So we're taking what we had originally, our old area, and our new area is 4 times our old area, our original area. So that means that we should know that, right? So what is 4 times 90? When you have 4 90-degree angles, 4 times 9 is 36, add a 0, 360, and that's what we got. So that's kind of what it wants you to do describing wise, so that's what we did, alright? So your exit ticket is similar to the ones we just did before, where you have to find x of the side length, squaring it, just like we did those 2 problems. Finish that up, and that will be it. Good luck on your test. Hopefully you guys go back and watch these videos a lot. I know there's a lot to go through. All of Chapter 6, Chapter 7, one section of Chapter 7, and then all of Chapter 11. There's a lot on this unit. The next unit will slow us down back again. Be nice and slow paced. All right?